Hey guys, welcome to another lesson. This week, what I'd like to do is switch gears a bit and introduce you guys to a completely new library and show you guys how we can use different tools that are available mostly for free on the internet, and we can bring them into our projects and do really cool things with them. So far, everything that we've been learning has been using the P5.JS library, right? So P5.JS, as you guys know, is this library that allows us to create kind of interactive visual experiences right in our browser, right? So we've been using this tool to draw things to the screen, animate things on the screen, interact with the user via different ways to interact with them through the keyboard and the mouse. Now, of course, all of this has been integrated into a website, which is using those core concepts of HTML, CSS, and JavaScript, right? P5.JS is a JavaScript library. What does that mean? That basically means that it brings a bunch of tools. It's like carrying a tool set with you to go to do a job, right? So it has things like a hammer inside of it, and a wrench, and maybe a drill, right? So for P5.JS, it has things like how to draw a rectangle, or a circle, or listen to a mouse click, right? These are all things that the P5.JS library does for us. Now, P5.JS, so far, we've been really just doing two-dimensional sketches with P5.JS. So everything has been on a two-dimensional canvas within HTML. Now, you can definitely do 3D with P5.JS, and we might actually have a lesson on that. Today, though, I'd like to illustrate how we can use a completely different library and how we would go about actually learning the library. So really the goal here is to not to comprehensively teach you this new library, which is going to take a lot of exploration, but it's almost, I want to show you how you would go about learning it using the knowledge you already have, right? So the library that we're going to be talking about today is Three.JS. So you can head over to Three.JS.org. And this is a library that's been in development for a pretty long time. It's a pretty mature library at this point. It's an open source library, which means that the source code for the actual library is available openly on GitHub, and it's basically a tool that allows you to do 3D on the web, which is kind of exciting, right? So you can go into Three.JS.org. You have a couple of options over here. If you can actually get the code to the full project by clicking on GitHub, and this is the actual code for the library, and it's open source, freely available. You can use it to build products and websites, just like P5.JS. All right, and the point here is that there are a slew of freely available tools that have years of development against them from many people. Right, this project has 35,000 commits. That means 35,000 changes to the library itself. Right, there's been 1,300 people that have contributed to this project. It's used by almost 40,000 people, right? These are big projects that are open and used widely in commercial applications and personal applications alike. So how would we go about actually learning this, right? So the first thing you want to look at when you see it, when you're evaluating a library to use, is how large is it, right? How many, is it still under development? Are there still people actually using it? Is there good documentation, right? If there's no documentation, it can become very hard to learn because you really need to know how to read the underlying code to be able to really learn it, right? So in this case, Three.js, right, this site here, and I realize I say right a lot. I'm going to try not to say right so many times when I'm recording these videos. So this is a bunch of demo sites that currently use this library. There's a lot of really cool ones. I think we showed off a couple in class maybe a couple of semesters ago. But if we click on one of these randomly here, let's see what this looks like. This is actually trying to translate to Korean, so we'll keep it in Korean. We probably won't be able to use it, but let's see what happens. Now, a lot of these applications, a lot like, oh, there we go. Here's some 3D going on. Now, a lot of the applications that use tools like Three.js are kind of these almost experimental and not your traditional website. So from a traditional, content first perspective, these typically are not those types of applications. These are typically highly interactive, unique applications that are, fitting some specific need, maybe a small micro marketing site or, an experiment. So like this seems like it's more of like kind of an experiment where we're dragging and dropping different 3D assets to build this little robot. And what I'm assuming is once we do this, we'll probably be able to maybe control this bad boy. Maybe not. He's just kind of rolling off there. Bye-bye, robot. There he goes. But this is, you can see here that we are rendering all this. Oh, look at this. This is cool. So we got all this little 3D stuff going on, and we got this robot traveling around this world. So this is all the type of stuff that's possible with 3D on the web today. And this is a highly growing aspect of the internet. The capabilities within our browsers are getting stronger and stronger. Things like CSS GPU acceleration, being able to leverage the hardware a bit more from the browser is going to enable experiences that just were not possible in previous years, right? So think about, oh, I said right. Think about having full interactive 3D experiences directly in the browser without having to download large pieces of client software and being able to just deliver these experiences using the power of the browser as your distribution medium. So it becomes quite powerful, and you can provide some pretty interesting experiences. This one I found really interesting. Corn revolutionized. So this little microsite for, I guess, a corn producer, and the visuals that they were able to achieve on this page are just stunning. You scroll here and it's got this beautiful DNA model that's coming in. And I know for a lot of you watching this, you are currently being educated in a lot of 3D interactive tool sets. So being able to take things that you've created in these very large, and in many cases very proprietary, unless you're using Blender tools, you can take these assets and bring them into tools like this and distribute them openly in the browser, right? Look at these beautiful models that are rendering here, the way that it's animating the scroll, right? It's just a really nice experience. It's not a traditional experience, right? So like a lot of folks may say, hey, it's hard for my users to navigate, and you should be mindful of that. This is not something that you're gonna, base your entire company's website on, right? If you go to this company's regular website, which I think it's just pioneer.com, you'll see that it follows more of a traditional type of flow when it comes to a web experience. And I think this is their site, right? Is this not loading? Okay, well that doesn't seem to be loading. But in any event, this is just another example. And there are a ton of them. I recommend that you go through here and just experiment and see what you can do here. Like you can render some pretty high fidelity models using a lot of different lighting with Three.JS. Right, look at this. This is pretty amazing. This is inside of the browser. Oh, it even has audio. So we're going to be able to deliver some pretty nice video game experiences right in the browser without having to deliver large pieces of software to machines, which is kind of nice. So really the goal of today is to introduce you to Three.JS, but most importantly, introduce you to how you would approach even learning any of this stuff, right? And this is where it goes back to documentation. So in the course, I'm going to link out to some of the documentation here on 3.js.org. If we click documentation up here, what I'd like to do is go through with you guys this first getting started creating a scene page. And this is going to take us through basically setting up a scene and then rendering some basic geometry in the browser. So why don't we go ahead and do that? What I've done is within the Stack Starter environment, so if we jump over to Stack Starter here and we click on Build within your environment, it's going to take you into your editor. Now, get out of that, get out of that. And your environment already has the Three.JS library loaded into the file system. So if you expand this libraries folder here, you'll see that we have P5, right? And we have the P5 sound library, the DOM library, we have the actions library. We also have 3.min.js. This is the actual JavaScript file that contains all of the logic to be able to render and use the tools that are within the library. We typically call this, like this is all compressed and minified, so it looks like googly gosh, right? So you're not gonna be able to actually read this code, but it's all minified, so we can pull it right into our projects. And this is simply just downloaded from the actual project, right? You go here, and if you go to Three.JS, you could just quickly download it right here, right? Boom, I get the zip file, and that zip file is going to contain the actual JS file. I just went ahead and brought it into your environment so we didn't have to deal with that. Now, with that in place, we can actually start to go through this tutorial. So let's take a look at this tutorial together. Now, the first thing we need to do, as with any web application, is to define a structure to be able to build the application. And what is the structure when we're talking about a web application? It's the HTML, right? I constantly go back to that. HTML is the structure of a web application. It's like the studs in the wall for a building. So we first need to lay out the studs to be able to actually create this application. So why don't we do that? And I'm going to actually type this out with you, right? So let's go into our project here. Let's do this together. We're going to create another file. So I'm going to go up here and click plus. And let's create a new file called Three.JS_intro.html. Okay? So we're going to call it Three.JS_intro.html. We're going to hit enter there. That's going to open up the file here. Now, let me keep this in this, let's go ahead and split this window so we can keep it together here. Let me close this. Okay, and we'll split this here. Okay, so now we can keep the tutorial up here. And now this is typically how you would go about, experimenting with a new library. So the first thing you do is you look at the documentation and you say, okay, where's some tutorials on how do we actually put this together? Awesome, we have a clear tutorial. That's looking like a good sign that this is a mature library that we can try to leverage for maybe one of our projects. So why don't we go ahead and follow this out? So I'm going to go ahead and type this out. Now you can copy and paste this, but being that you guys are starting out in this world of development, I would recommend you type it out because this gets you a little bit of muscle memory. It also enables you to make some mistakes, which you're going to make, right? You're going to make a syntax error. You're going to miss something that is going to break the application. And going through that process of figuring out what went wrong is probably one of the most valuable aspects of the learning process for these topics. Because by doing that, it strengthens your knowledge for how to navigate issues when they do inevitably arise, right? So we could just simply copy and paste this, but you're going to take a bunch of things for granted, like making sure that you close the body curlies in this little style, or making sure that you close the style element properly within the head, right? All these little things that by just simply copying and pasting things isn't going to help you. Now, when you're in practice and you're doing this professionally and you've got a good grasp on a lot of things, you do that a lot. You do copy and paste code. That happens, right? There's a lot of jokes in the communities about like you just go to Stack Overflow, Stack Overflow, and you're just looking for answers to your questions and you just grab the code, right? Totally happens. But in this case, let's type this out together. So the first thing we want to do is we want to declare that doc type. So I'm going to go ahead and declare the doc type. Now, an HTML document, as you guys know, opens with the HTML element. And now underneath that, we have two children elements, which we have the head, and then we have the body. Now, luckily, this editor does do some things for us, like it does close the element for us when we open an element, so the closing head and the closing body are automatically edited for us. Now, let's go ahead within the head. Let's match what we have in this tutorial. So we're going to set some metadata here with a meta tag, and we're going to give it a character set. This basically tells the browser exactly what character set the document is in. I'm not going to go too much into the details for that, but we'll just go ahead and add that. Now we're going to go ahead and add a title. So the title is basically going to be what's rendered in the tab in the browser. So we'll go ahead and say my first Three.JS app. Okay, so now I'm going to close this file. There we go. Make this a little bit bigger. And now what we want to do is we want to embed some styling. So this is some basic styling that just collapses the margin or makes the margin 0 for the body element so that everything is kind of flush against the window, and also make sure that the canvas element is a block display type element. Now that's fine. That's just kind of some boilerplate styling. Doesn't really have much to do with actually rendering 3D to the browser. So let's go ahead and duplicate that. I'm going to go ahead and open up a style element, and then we're going to give it a body margin 0 and canvas display block. Notice I'm putting the semicolons at the end of this. I'm closing these curly brackets exactly how you see here in the actual tutorial. Now, that completes the head section, right? So the head section is done. Now let's go ahead and dive into our body. So now within our body, we're actually going to bring in the Three.JS library. We're going to do this in the body because it's going to download the JavaScript file slightly different than if we put it in the head, which means it won't actually block the output. So the output of the page will render in the browser, and then the JavaScript will come down, as opposed to putting it in the head, which would wait for the JavaScript to actually download. Not really a big deal for this task, but just something to keep in mind. So let's go ahead and open up the script. And now we have to add an attribute to this script element, giving it the source. Now, the source is going to be different than what's in the tutorial because the source is living in the libraries directory, and it's called 3.min.js. So instead of doing exactly what's in the tutorial, we're going to have to say source equals libraries. Ooh. And notice how the editor kind of tries to autocomplete this for us. So I can click libraries, and then it'll ask me what file within that directory you want to actually select. So I'm going to go 3min.js. Boom. Now we'll go ahead and close that script, and that'll automatically close the script element for us. Now, right below it, we're going to add our own custom script. So I'm going to go ahead and open up a new script element. I'm going to close that. And now we'll hit enter there. So now here is where we will write our code. Okay, so we're cooking. So now if we go ahead and try to run this, so if we go back to Stack Starter here, I click run, and I'm going to click on the Three.JS intro. We should have a blank page. We should have a blank page, and the title should be my first Three.JS app. Awesome, looks good. Now we can kind of prove out that we are doing something here by maybe giving the background color of the body a black color. Right? And there we go. We can see that we're actually interacting with this page, and it is doing something. Awesome. Now let's go ahead. I'm going to take that out because we'll keep the background color white. And we are looking good. So now let's go ahead and let's continue down this tutorial. So there are really 3 things that we need to set up a Three.JS scene, right? And it's explained right here in this tutorial. So we need a scene object, we need a camera object, and we need a renderer. Now, for those of you that have been studying 3D applications like 3D Studio Max or Maya or Blender, this may seem pretty similar to what you've used before, right? If you start to do some 3D authoring, typically you need a camera, right? You have a camera, and that camera is what's connected to your renderer that is able to now figure out what pixel goes where so that you can actually render scenes, right? So it's the same principle within Three.JS. The only thing is you're actually writing the code to do it. So you can think of it the same way as you would in a GUI, like a graphical user interface application, where you've got buttons that you can click and you can drag things out. You're just typing the text out, right? So it's really the same exact thing. And really on the back end, the code within a lot of these authoring applications, this is exactly what's happening. So in many respects, we're kind of peering under the hood a little bit and seeing how maybe some of this stuff fits together. Of course, there's another hood you can peer under if you look into the library itself, right? That's where you get into some of the perspective math, and it gets a little more mathy inside of that, right? You're going to look at linear algebra and matrices and all that type of stuff. So let's go ahead and let's set up some of these objects. So this touches upon the idea of object-oriented programming. So we're using this new operator to be able to instantiate or create different objects based on classes that are defined within the library itself. Remember, when we talk about object-oriented programming, you have this idea of a class which defines a blueprint that you can then use to build an unlimited amount of objects in your programs. So some of the blueprints that are defined within a 3D library like Three.JS would be things like a scene, a camera, and a renderer. So that when we correlate this back to a toolbox, the toolbox doesn't contain a hammer, it doesn't contain a drill or a wrench. It contains a scene, it contains a camera, it contains a renderer, and it contains other things as well. But these are the type of tools that come in these libraries. So think of it as a toolbox where the tools are a little different than your handyman special tools, right? So let's go ahead and set this up. So we're going to say const. Now const is a type of variable that is constant. It's not going to change throughout the program. So we're going to say const scene equals new 3.scene. Now we can call this 3.scene because we brought in the library here, right? So if we go back to our application and we open up our console, we shouldn't see any errors here. If I go ahead just for illustrative purposes and delete this, you're going to see 3 is not defined. This is not defined because we didn't bring in the toolbox, right? The library is not brought into the structure of the page. So by doing this line here, we're bringing in the toolbox. It's literally bringing the tools to the job, right? So let's go ahead and continue to build this out. So the next thing we're going to need is a camera. So let's go ahead and say const camera equals new 3.perspective camera. So because it's called a perspective camera, that makes you think that there's probably different types of cameras, right? So the perspective camera takes a few parameters here. So we're just going to go ahead and put the same parameters that are in here. So it takes the window inner width divided by, so the aspect ratio of the window is the second parameter, right? Because we're dividing the inner width by the inner height. And then we're going to take these two variables, which we can go ahead and reference the actual reference for Three.JS here. I'm sure there's a reference on these methods that are on these objects, actually the constructor of this object in this case, and what these parameters actually do. For now, let's go ahead and follow along with the actual tutorial. So now we have a scene and we have a camera. Awesome. Let's make sure that we're still not getting any errors in our console. It looks like we're clean. I'm going to go ahead and clear this. Okay. So now the next thing we're going to need is a renderer. Now the renderer is going to be able to actually render things to the screen, right? So we're going to go ahead and say constant render equals new 3.WebGL render. So there are different types of renders that we can create. In this case, we're using a technology called WebGL. Now, WebGL is really the core technology that allows us to render 3D in the browser, right? So if we go ahead and look at WebGL, this is going to show you if your browser supports WebGL, but WebGL is part of the OpenGL project, which I believe this is going to be a bit more technical information because it's really the library that's underneath Three.JS. Remember, there's always another layer we can peel back. There's always another hood we can open up until we get down to the actual hardware of a machine. But WebGL is a library that includes a lot of different tools that allow the primitives of building 3D objects within a programming environment. And a lot of tools are built on top of WebGL. OpenGL is one that's used for a lot of desktop applications. You may have heard about it. Like things like 3D Studio Max and Maya. They implement many aspects of OpenGL within their environments to be able to create those types of tools. So think about if you wanted to write 3D Studio Max, you would use OpenGL libraries to be able to do a lot of the 3D aspects. They don't write that stuff from scratch in many cases. In some cases, they probably do. Those are big, mature applications. But they most likely leverage OpenGL. Another one, the Microsoft technology, is called DirectX, which you may have heard of. So these are all lower level 3D libraries that we can use to create applications that leverage 3D. In this case, WebGL is really the kind of de facto currently for rendering 3D in a web browser. So let's go ahead and continue here. So the renderer, we're going to call the setSize method. I'm going to give it the window.innerWidth and window.innerHeight. Okay, so we set the size of the renderer to be the size of the window. So we're setting the size there. And now here is where we're going to use a different library to be able to actually attach this to a web page. Now, this is everything that we're using here, we're saying a library, but when we call these functions, this is what defines what we call an API, or an application programming interface. It's how we as programmers interface with the programs to be able to do things. So we can create APIs, and those APIs are then used by other programmers to be able to leverage our tools. So it's like, if we correlate it back to an actual tool like a wrench or a hammer, it's like the shape of the handle on a hammer and how we grab it is the API, or the interface to the human, right? So we are using APIs within our libraries to achieve things. And the browser itself implements a collection of APIs that allow websites to be rendered. One of those APIs is the actual document object model, or the DOM. And that is represented in our browser by a single object called the document. So if you go into any page and you go into the console and you just type document and hit enter, you'll notice that this represents the actual HTML that we wrote. So you can see here the document itself is an object which consists of the actual HTML. Now technically, this is not HTML at this point. This is called the DOM, or the document object module. Document object model. So each one of the elements that we wrote in text here is translated to a node that then has, it's basically all objects. So everything has methods and properties to it that we can use to manipulate the page at runtime, which means we can change the page when our code executes. Very, very powerful. So that's exactly what this line of code is doing. We are going ahead and leveraging that document, and we're saying that the body, which is the element here, right? This actual element on the page, we're going to take the body and we're going to append a child to it, or append an element to it. We're going to use the append child method, and we're going to say use the renderer's DOM element. So the renderer's DOM element in this case is going to be a WebGL renderer, which is going to be a canvas element. So if we go back here and we take a look, we now see the page is all black. And if we inspect the page, we now see another element that we did not write in our HTML, a canvas element. And it is the width and the height of the window. So look at that. So this did create and add a renderer to our page. So we now are looking at not just a blank white page, but the actual canvas that represents a WebGL renderer. So this is technically now a 3D environment that we can throw geometry on. Super cool, right? It's not visually nothing right now, but we're building up to the point where we can actually render 3D. So I recommend that you go here and read through all of this stuff. But now the next piece of this is, let's go ahead and render some geometry to the screen. So if we go here and within the script itself here, I'm going to go underneath the document.body, and we're going to go ahead and create some geometry. So I'm going to say const geometry equals new 3.box geometry. So this is a method that's on the 3 object that's going to allow us to grab some pretty basic geometry for a cube. Right? So we're going to go ahead and make sure we can type geometry. Now the geometry is also going to need a material, right? So the geometry only represents the vertices and the edges that connect those vertices in space. So you can think of it as like a, we touched upon the idea of arrays, but really an array, or a multi-dimensional array in many cases, that keeps track of the specific numbers, the coordinates in space, and the connections between those coordinates. It does not define the look of the geometry, how it should look. That's where materials come into play. So we can set up materials that wrap or connect to that geometry to give it its visual aspects, right? So if we go here and now set up a material, so we have our geometry, and now we have to set up our material. So mesh basic material. And as you would imagine, there are a ton of different materials. And for those of you that do 3D application work, you probably do create materials yourself in these tools, right? That have different aspects to them, like shine values and things like that give you how it reacts to maybe lighting in the scene and things like that. You could do a lot of that stuff in this as well. So for this one, we're just going to give it a basic color. In this case, this is the hex value for red, right? Because we have RGB values. So we're going to say hexadecimal value, actually, I'm sorry, it's blue, it's green, RGB. I'm not reading that correctly. So the first 2 is red, the second two is green, and the last 2 are blue. So that's going to be actually green, not red. So now we have that. That's looking good. So now we have our geometry, we have our material, and now we need to bring it together with a mesh. The mesh is going to bring those 2 things together into a cube. So I'm going to say constant cube equals new 3.mesh. And let's go ahead and bring in the geometry and the material as the parameters to this mesh object. And now at the end of this line of code, let me move this over slightly here. See if we can see if the menu will the menu collapse here? Ah, it will. Nice. Okay, so let's do this. Let's bring this over a little bit more. Okay. So now we have our cube, but it's not going to actually render anything yet, right? It's going to just be in memory, right? It's not going to do anything. If we go back to our application, there's nothing there, right? So what do we have to do? We actually have to add this mesh, which we called cube, to the scene. So we created a scene up here, and this scene object allows us to build what we call a scene graph, right? And I don't know if 3D applications have these ideas. I think they do, where it's basically a hierarchy of geometry and objects that are drawn to the screen. So let's go ahead and say scene.add. I'm going to go ahead and add that cube. Boom. Now, if we go ahead and we should see something at this point, I believe. You know what? We probably won't because we're not actually rendering it yet. So now the scene has the cube in its scene graph. We added it to it, but let's continue to go down this. So now we need to point the camera. It is rendering, but we didn't point the camera yet. So the camera is sitting at 0, 0, 0, right? Because we have 3 coordinates now. We have the X, Y, and we have the Z. We now need to move the camera back a little bit. So you can think about it, if you can't see me, but if the left hand rule, right, where you have your thumb pointing out, your pointer finger pointing straight, and then your middle finger kind of pointing up, and that symbolizes the X, Y, and Z coordinates. The Z coordinate is pointing directly into the screen, right? So the positive direction is back and the negative direction is in, right? So if we go ahead and move the camera's position back a bit, we should see the cube. So let's go ahead and do that. So we're going to say camera, which we created up here. Keep doing that with this editor. Camera dot position. So there's a position object, and that has a Z value in it, and we're going to make it equal to 5. And now still don't see anything yet. So let's see. Because we are not rendering it yet. So we're still kind of setting up this scene. So again, I recommend that you go through this and read this. But let's go back down. Okay. So the way that Three.JS works is there's this animation function that that we can call, and it's going to put the program into a loop. Now, being that we're coming from P5.JS, this should be pretty familiar to us, right? We have the idea of the draw function in P5.JS is this main loop function, which is always being called. Does anybody remember by default how many times the draw function in P5.JS is called? It's called 30 times per second, right? So this is very similar, but it's a little bit more manual with Three.JS, just slightly. We need to define this function. We're going to define it right here. It's going to be called animate. And this is kind of going to bootstrap our application to start the engine, so to say, for requesting animation frames and starting the actual scene and rendering it. So we're going to say animate request animation frame, which is a function that's part of Three.JS. And this is going to take as a parameter a function name, which is called animate, which we did here, which is going to call itself. This is called recursion. It's calling itself, which is starting this kind of infinite loop, right? And then in this, we're going to say renderer.render. So we're using our renderer now to render the scene as a parameter using the camera we have set up. So we can actually have multiple cameras in a scene, and we can render them using this render method. Super cool. Now, is anything going to happen yet? It's not, right? This scene is still no action going on. What the heck? We actually need to call the function to make it work. So let's go ahead and say animate. And now, boom, we have what looks like a square. Is that 3D? That doesn't look 3D to me. What's going on here? What is going on? So what's happening here is the fact that this is a cube, but it's not rotated at all, so we can't actually see any of the 3D geometry. It's just, we have a camera pointing directly at one face of this cube. So let's see how we can fix that. So let's go ahead. The cube, the mesh itself does have some properties that allow us to manipulate the X and Y of the cube. So we're going to do that directly in the animate function, because the animate function is going to be called over and over again. So what we can do here is, this is where we can manipulate our mesh to animate it. And what we're going to do is, we're going to simply say cube dot rotation dot x plus equal 0.01, and we'll do the same thing for cube dot rotation dot y plus equal 0.0.1. And now we should see, boom, a nice 3D rotating green cube. Now the material isn't all that exciting because it's kind of, you can't really see it. Let's go ahead and let's go off the beaten trail a little bit with this tutorial. That actually ends this tutorial here. So we actually got through that whole tutorial, and I hope that you guys played along. If you did not, you could totally go back and press pause in any section of this video and play along. It's mega helpful to go through these tutorials, and I really wanted to illustrate how would you approach learning something like this. And this is really the stage one, is going through this. So let's go ahead, and I'm going to just Google real quick the 3.basic mesh material, and this should take us right to the docs. So you can see here, now we're looking at only this object, the basic mesh material, and I want to see what we can do with this. So you can see we have all these different, we have light maps, reflectivity, skinning, wireframe. Renders geometry as wireframe. It defaults to false. So let's go ahead and try that. I'm going to say cube.wireframe equals true. Okay, that didn't do anything. Let's see. Dot wireframe. This is pretty cool. There's a little kind of tool here that we can use to show off, like here we said wireframe. So what did we do wrong? So it's probably within the parameters that we pass into this. So we, instead of saying wireframe, which maybe we just wireframe. No, we spelt it right there. And this takes in a parameters object. Is there a way for you to dive into the code with this? Okay, so this is good though, because this illustrates how you would go about kind of diving into some of these documents and figuring out exactly how this stuff works. And I guess I must be missing something in terms of the wireframe renders as flat polygons. We don't want it to render as flat polygons, but it's Boolean, so it should just be a wireframe is true, cube. So wireframe, maybe this is just, this might not be it. So that looks like it is not a function. So it's not a function. We should be able to just say true That doesn't work. Is it because... Oh, because you know why? Because I'm being, I'm not paying attention. So I'm looking at the mesh basic material. And so hopefully somebody just picked that up. I was using the mesh, not the basic material. So we're talking about the material here. So really, we are passing in this object here. This is using an object literal notation is what we call it. So what we could do is we can actually just go here and then say wireframe, and we'll say true here. Now, there we go. So now we should see the actual wireframe basic material in that color. And we can play around with this a little bit. We can make it red if we wanted to. Maybe make it rotate a little bit faster in the X position. All right? And just kind of play around with this. So I'd like to end this here. So we went through this introduction of Three.JS. What I'd recommend is go through this with me and then maybe play around, right? So we have different types of materials that we can use. There are also different types of geometry, right? We have all this different, look at all these different geometries that we can pull up, like dodecahedron. We can render a dodecahedron, a cylinder, cone. You can also load your own geometry. So this may be interesting for some of you guys to do if you have some models that you've created. There in this manual here, there is this section for loading 3D models. And you can load 3D models from all these different tools. Blender is one of them. There are some open formats as well. I think it's they recommend the GL transmission format, GLB. So you guys may be able to get that format outside of some of your 3D applications. So this may actually be a second part of this tutorial, is to look at some 3D models. But see what you guys can do with this tutorial. If you guys have any questions, please let me know. And have fun, experiment, and just work out your knowledge of typing a lot of the syntax out if you really want to learn this stuff. All right, guys? Thanks.